Okay, so now we're going to talk about the regional function of the central nervous system. And it's highly related to the nerves. So the nerves are bringing information into the nervous system, taking information out from the nervous system, taking motor information out, bringing sensory information in. And the function of the various parts of the nervous system are related to what nerves are coming in or going out from that area. So let's just start with the areas that we're talking about. We've talked about the spinal cord. The hindbrain, which is this area, includes the pons, the cerebellum, and the medulla. The midbrain includes only the midbrain. And then the forebrain includes the hypothalamus, thalamus, or interbrain, and then the endbrain, which is the cerebral cortex, an area called the basal ganglia, and the amygdala. And I have this cerebellum is this dotted line here, just in case. So now what we're going to do is look first at, I believe, sensory information coming into the central nervous system. So what we see is that the spinal cord is getting information from the body. It gets information up here in the cervical cord from the arms. In the thoracic cord, it gets information from the trunk. In the lumbar region, it gets information from the legs. The other sensory information of note is hearing and vestibular information, which come into the caudal part of the back part of the hindbrain. And then there's somatosensory information from the face, top of the head, and the oral cavity. And that's all going to come in to the brainstem and into the pons. Now, vision, as you know, is actually not coming in from the periphery. It's actually already part of the central nervous system. The retina is part of the central nervous system, but that retinal input comes into the forebrain. It arrives in the thalamus, actually. And then smell information comes in through that cribriform plate into the forebrain. So that's how different types of sensory information arrive in different levels of the central nervous system. Now let's look at the motor output, and we're talking about voluntary motor output, skeletal motor output. And back down here, we have leg and foot movements in the lumbar cord. Up in the cervical cord, there's arm and hand movements. Of course, the thoracic cord enables us to move our trunk, but we don't do that spectacularly well, so it's not a highly, I don't list it here, it's not one of the bigger movements that we make. But swallowing and speech and the gag reflex, the ability not to choke, this all comes from the back end of the hindbrain, from the medulla. So you need motor output from the medulla in order to swallow, in order to speak, and in order to save yourself from choking. And from the pons, we get two major types of movement. One is facial expressions, the ability to make different facial expressions with our face, and also the ability to move our eyes in to the side. And so when I look like that, this eye, this is all horizontal gaze, the ability to move my eyes to either side depends on the pons. In contrast, our ability to move our eyes vertically depends on the midbrain. Another function of the midbrain is the ability to fixate on something that's very close. So if I want to read, I actually have to move my eyes together. I have to converge them, and that also comes from the midbrain. So you can see that the motor output from the nervous system is really split between the spinal cord and the brainstem. there's absolutely no motor output from the forebrain, either from the thalamus, hypothalamus, or from the cerebral cortex. Okay, and then finally, if we add in the autonomics, what we'll see is that, so I'm including everything. This is all in blue. This is all of our sensory information coming in. In red, this is all of our motor information going out. And in this brown are the various autonomic connections. And so this is the parasympathetic, back here in the sacral cord arises parasympathetic outflow to the colon, the bladder, and the sex organs. The entire sympathetic outflow, which is required for fight or flight, for really getting jazzed up and in survival mode, comes entirely from the thoracic cord. The parasympathetic outflow to the body comes from the brainstem, from the caudal, the back part of the brainstem, and the parasympathetic outflow to the eye comes from the midbrain. And there's some other parasympathetic stuff that goes to, say, our tear ducts and salivary glands and things like that, that also come from the brainstem. There's one other automatic outflow, and it's not either parasympathetic or sympathetic. It's that the hypothalamus has a very privileged interaction with the pituitary gland. And so the hypothalamus can control hormone release from the pituitary gland. In the next segment, what we're going to do is we're going to look at how information ascends and descends through the central nervous system, because even though information, say somatosensory information from the legs, comes into the spinal cord, in order to ever make any sense of it, it has to end up in the cerebral cortex. So how do we get from the outside to the inside, or from the inside to the outside in the case of a motor outflow? And that's what we'll do in the next segment.